Welcome everyone, and thank you for joining us today. This is our fourth edition of webinars by VergeCloud, and today's topic for the day is Application Security 101. We will be looking at how application layer attacks, how they move, and where the gaps usually are. So today we have Arshad Parvez with us today. He's the solutions engineer at VergeCloud and an expert at application securities. Handing over to you, Arshad.
Thank you. Thank you for joining, everyone. Thank you, Jane, for the introduction. As Zain mentioned, today's our discussion or the topic about this webinar will be Application Security 101. And through this webinar, we'll be able to understand what kind of threats are applications facing at the moment in this and plus Indian application threat landscape. So that will be the main agenda behind this session today. But to set the expectation right, we are not just going to leave with a beginner glossary about what kind of security problems or what kind of problems and applications are facing in general. Instead, we'll be leaving with a clear picture of what kind of attacks are happening against any web application in general, and how applications security stack works in a layered defense approach or in a layered manner to mitigate these attacks, and where it fails, where it has to be enforced, and things you can do on at your level to reduce the application exposure to mitigate these kind of attacks. So these are the things. This will be our agenda today, this session. And the second thing is that we'll be primarily focusing on India-specific landscape. The reason being is that Indian threat landscape has a huge, you could say, curve compared to the global trend. Or if to put it in a different term, our threat landscape is higher compared to the global trend, and it's diverged. The attack against Indian landscape applications are diverged, whether it is SMBs, whether it is mid enterprises, whether it is large enterprise, or banking BFSIs, on manufacturing organizations. These people who are operating in India are facing attacks which doesn't match with what kind of application security stack they are having at the moment. So these gaps is what attackers are exploiting to let's say to compromise them. So these are the things we'll be understanding through our webinar today. Now let's start with some data. So if you notice on my screen, you'll be seeing two different lines. On the graph, you'll be seeing two different lines. One is the orange line, which is indicating Indian trajectory or trend, Indian attack against Indian businesses trend. The second thing is global trend. If you notice that, if you compare the Indian attack trajectory trend against the global trend, it is almost 4 times higher compared to the global average. The reason being is that India is exponentially growing. Indian businesses are exponentially growing, and on top of it, Indian users are coming online more and more compared to the global average. So due to our increase in digital presence, we are facing like these attacks, and attacks against our business are increasing more and more. So that is one of the reasons where attackers are primarily focusing against Indian businesses. The second thing is that if you notice at the numbers at the right side, so these numbers were based on the last 2 years, like attacks, breaches happened. So these were the numbers for the which was collected from the past 2 years. So if you notice in the 2024 alone, almost 7.15 billion attacks were blocked, and these were all attacks which were blocked. So imagine or think about the attacks which were unblocked, which are not reported. So these are attacks which were blocked and reported. And the second thing is that if you notice, on average per year, Indian businesses are facing almost 7 million attack compared to global businesses. And an organization on average, they're facing almost 3,000 plus attacks on average, and any individual organization per week they're facing almost 3,000 plus attacks. So this is the second highest. This number is second high. We are in the second highest in APAC region if you compare this number. And what kind of industries which are getting targeted? If you notice, retail businesses, For example, they are facing DDoS attacks. There have been surge of DDoS attacks against them, more than 400% in the past 2 years. And manufacturing industries or manufacturing organizations are facing attacks more than 300% compared to what they were facing in the past years. And if you notice the industry, in insurance service provider industries, they are facing more and more attacks, more than 300% of different kinds of attacks. So not only DDoS attacks, different kinds of attacks are getting happening against their environment. And when you compare the BFSI sector, two times more compared to the global average. In general, BFSI banking systems will be a potential, or it's an ideal target for any attacker group. But if you notice, in India alone, BFSI segments are getting targeted more and more compared to the global average. Now, if you imagine right now in the current time, and where people are now leveraging artificial intelligence tools, machine learning algorithms tools, to do autonomous, semi-autonomous, not completely autonomous, semi-autonomous attacks against any application which are exposed to the internet. Now, if you include that and consider this data, this is an you could say a trajectory which we can imagine increasing more and more, not reducing. So that is why our systems or our businesses which is running in India has to focus and invest more on security to mitigate the upcoming attacks, or the attacks which they will face, obviously, in their application which are exposed to the internet. Next slide. Let me move past. Now, these are some key breaches which I have included in this slide. So all these data breaches was part of 2024 data breaches. So these were some valuable data breaches. That is the reason why I mentioned this in our slide. But even in 2025, there were some key data breaches like Zoomcar data breach, Airtel data leakage. So these kind of data breaches even happened in 2025. But if you noticed, all these data breaches, Boat or Hathway or Star Health Insurance or BSNL ISP service provider or network service provider, these are all household names, and these are all well known businesses across India. That is the reason I mentioned this part of this deck. If you notice, now talking about the breach which has happened at Boat data breach happened in February 2024. Almost 8 million plus customer data were exposed or were leaked due to misconfiguration, and these data were sold in dark web for almost $10 to $15. So for $10 to $15 rupees, for $10 to $15 value, and attackers were selling these data, Boat customer database, they were selling in the dark web. So think about that. So now the reason why this attack has happened is that because of a database breach, this database was not really configured and it was misconfigured. So that is the reason this data breach has happened. So this was basically a negligence, or you could say this database were not properly taken care of. That is the reason because of which attackers were able to hijack it and exfiltrate the data out of the database. In the next data breach, if you notice, Hathway data breach. The Hathway data breach, what happened is that pretty much more than 40 million records, customer records, were exfiltrated out of the system due to an vulnerability in their content management system. So they had a CMS system which was vulnerable to a specific CVE, and attackers were able to utilize that, and they were able to compromise that specific system because it was left unpatched, and that vulnerability was not patched at Hathway side, and due to which attackers were able to exfiltrate data, and they were able to also publish and sell this data across the dark web. The next thing, if you notice, the data breach which has happened at Star Health, what happened is that pretty much this was due to an unhygiened configuration happened at their API endpoint. So basically what happened is that their API endpoint was exposed to the internet, and on top of it, their API endpoint were not properly, the users were not properly authenticated because there was no proper authentication chain was implemented at their API endpoint, due to which the attackers were able to find out the exposed API endpoint which is in the internet, and it was having improperly configured authentication process, and they were able to pull out the records from the Star Health insurance application. So these data were medical records, which was having sensitive PII identifier information such as Aadhaar information, PAN information, so on and so forth. So even these were sold in the dark web. These attacks were actually not by any state-sponsored attacker groups. It was just by small attacks. The reason this breach happened because of an API misconfiguration or properly unhygiene configuration. And finally, the last data breach, which was like high-level data breach, which happened is that BSNL data breach. Pretty much almost 300 GB of data were exposed, and people were able to take out this data because of an leaked snapshot, server snapshot. So basically, BSNL engineering team were taking their server snapshot, and it was exposed in the internet. And people were able to, attackers were able to identify it, and they took the snapshot, which was accessible via internet, and they were able to replicate all the content in it. Because of it was an encrypted database, and people are able to pull out all the information and sell it across the internet. So if you notice all these patterns, if you notice all these data breach, you'll notice that all these are due to like small misconfiguration or unhygiene practice or unencrypted databases or unpatched systems. So these are all not sophisticated attacks, which means this is at the same time which can be addressed, which is a good news. At the same time, it is a bad news that in our industries across India, people are now not properly taking care of their application systems. So that is why it is a mandate, or you could say that is why it is necessary for any team to understand the application threat landscape, so that they can implement these security measures against their application to safeguard their customer sensitive data. Now these slides, the next two slides, I'll be talking about some misconceptions every organization or in general SMBs or mid enterprise companies have. So that is what I'll be talking about in the coming few slides. So primarily, what are the misconceptions I notice in day-to-day basis when I'm interacting with customers is that for any requirement purposes when I'm interacting with them is that they believe that they are, just because they are hosted in any cloud service provider, whether it can be GCP, AWS, Azure, or any managed service provider, cloud service provider, they assume that, or they assume they are protected against any kind of attacks, which is unfalse, which is actually a false notion. The reason being is that these hosting service providers or these cloud service providers are only responsible for providing infrastructure service and taking care of the infrastructure and taking care of security at the infrastructure layer. They are not they don't need to implement any security measures against the application layer. Meaning, what happens is that there is something called as shared security or shared responsibility model, where the hosting service provider will take care of the infrastructure, and the customer has to take care of his application business critical applications. You need to safeguard it and you need to maintain it. So that is what the shared responsibility model is. If an organization or if a company is aware about this, so they won't be having this misconception. On the left side, if you notice, these are the things an hosting service provider generally takes care of. The hosting service provider generally makes sure their servers are up and running. There is no faulty hardware. They make sure their OS are properly patched, and they make sure the network activity is in place, and they make sure layer 2 or you could say layer 3 or even network level firewall is in place. This service provider doesn't need to implement security measures against a customer's application. That responsibility completely lies with the customer itself. And for example, implementing application security stack to protect their application logic and API endpoints, to make sure there is no malicious content part of the any HTTP transaction or any HTTP transaction happening against their application, to mitigate bot attacks, which mimicking legitimate user behaviors, or to even mitigate layer 7 DDoS attacks, meaning DDoS the attack at the layer 7 level, to stop any top-10 web application attacks, DevOps attacks. So these are things which has to be completely taken care by the application owner or the application owner organization. It is not part of the service, or it's not part of the solution where hosting provider needs to implement it for their customers. This is one of the primary misconception due to which applications are not properly implemented or properly secured, and it's getting exposed, and attackers are targeting against this misconception. And the next thing is that even though now what happens is that even though now let's say a customer is having an application security also in place between their client and their application origin, they will have these misconception. They will assume because of our security in place, they won't do an verification, or they won't have implemented the security properly. The security won't be properly in place, due to which the attacker will be able to pretty much bypass the security system which is in place and still compromise the application. One of the primary assumption is that I have a WAF in place. Now my WAF will be able to mitigate all the attacks. But if you know, for security people in the room, or who are already having a security tool in place, and you're already on database or interacting with it, they'll be aware that once you implement a web application firewall in front of your application, that web application firewall will be running in something called as learning mode or redirect mode or reporting mode, because in this time period, the web application firewall will be trying to understand the application traffic pattern and baselines of the application. So this is the out-of-the-box configuration for any WAF solution provider will provide. And what happens is that once that is implemented, customer will assume that, okay, now WAF is in place, now I'm protected. But the thing is, reality is that WAF is still running in detect mode, due to which attacks are actively happening, and it is getting logged, and it is, the operation team can see that logs at their dashboard or the control panel. But attacks are now actually landing at the application side. It is not getting mitigated. That is one false assumption customers have, that just because I have a WAF in the default settings, or I have implemented the WAF, without verifying that WAF is actually blocking the attacks. So this false assumption, attacks are still reaching the application. The second false assumption customer has is that, oh, my WAF is in place, my origin is now completely protected. But the thing is that if your origin IP is publicly resolvable, it is publicly accessible from the internet, attacker can actually bypass any layer in between, whether it is CDN layer or WAF layer. They can completely bypass it unless and until you properly lock down your origin. Meaning, you need to make sure that your origin only will accept traffic when the traffic is coming via your edge layer or your WAF layer. If you directly bypassing, the attacker is, or anybody is bypassing the layer in between and reaching your origin, it should be dropped. So this, because of this false assumption, and because of there is no proper lockdown in place at the origin side, attacker can bypass. They can end up compromising the application. So this is one assumption which has to be rectified, or this has to be explained, or this has to be conveyed to the application owners. The final assumption is that even after implementing all the security mechanisms, still based on how you configure your application security stack, or if you run your application security stack in the default parameters, there are possibilities, or there are possibilities that attackers can still bypass your security mechanisms in place and reach your origin. So to prevent that, ideally, once you implement an application security stack in between your clients and your application, you need to make sure that all your WAF is, or your application security stack is mitigating all the attack. At the time, what ideally and any customer will do is that they'll use some kind of tools to do some like benign attacks, and make sure that application WAF or any application security stack is blocking these attacks. So, but the thing is that this test, or this like efficacy testing, has to be done in a way that, to make sure that this is blocking that specific attack. Let's say if an application owner is generating some kind of bot traffic, like benign bot traffic, to test the bot engine, they need to make sure they're only evaluating that specific bot engine module. Because sometimes the engine, for example, what happens is that, let's say if you're testing the efficacy of the WAF engine, and bot engine is also running parallelly, if you run the test against the bot engine, against the WAF engine, but bot engine will work in front of the WAF engine, meaning it will first work before the WAF engine, and it will stop these attacks. And due to this engines, a bot engine, like any benign attacks will be blocked, and customer will falsely assume that, okay, my now application security stack is properly implemented, and I can move forward. So that is why proper sanity check has to be implemented or done to make sure that all the engines are working in hand to hand and properly mitigating whatever they are supposed to do. So let's say a WAF is supposed to mitigate a top-line OS attack. A bot engine is supposed to mitigate bot attacks. A DDoS engine is supposed to mitigate DDoS attacks. So that has to be properly validated and checked. So this assumption also has to be educated, or this has to be informed to any application owner. Now that we understood what kind of attacks any application is facing, which is exposed to the internet, and about Indian threat landscape, and what are some common false assumption or misconception any application owner has. Now let's come talk about the security layer, like application security stack. What is an application security stack, and how it should be a layered approach, and how each layer will work in tandem, and how the traffic will flow through them, and how it will mitigate all the attacks in the web application is facing at the moment. So we'll focus on this from the coming slides, on the upcoming slides, and moving forward, we'll focus on it. But if you notice now from on the left, if you notice from the internet, meaning clients or any client, whenever their traffic is passing through any industry grade web application stack, this is a web application security stack. This is how their traffic is passing through. First, their traffic is landing, for example, at the WAF layer, where WAF layer will inspect the layer 7 request and response, identify known attacks using OAuth patterns, and stop top-10 OAuth attacks. In the next layer, it will end up, the traffic will pass through the API security layer, where the traffic will be validated against this API security module. And then the traffic will go to the DDoS mitigation layer, where the engine will mitigate all the DDoS attacks, layer 3 to layer 7 DDoS attack. And then the traffic will fall at the bot filtering layer, where the bot attacks will be filtered. And then finally, the traffic will pass through the custom application firewall layer, which will be implemented by the application owner based on their application logic. So finally, the traffic will pass through this final layer, and then only it will reach the origin. Likewise, the response also will flow through these layers and then reach the source. So this is how a layered security approach works, and this is what been implemented across the industry by any solution provider. This is what has been followed. So in the coming slides, we will be going through each of these layer in detail. So to understand in detail how these layers are working. Now, for layer 1, WAF, which is the well-known, you could say, security control by anybody. Like WAF, pretty much people understand what is a WAF is. What a WAF will do is that, based on signatures, which is part of this WAF engine's signature rule set, or you call it as signature engine. Based on the signature, all the traffic will be scanned, or you could say will be passed, and it will be scanned, and it will be whenever there is a pattern which is matching this signature, that will be flagged and that will be blocked by this WAF layer. That is what at an high level WAF will do. Let's say traffic is now flowing through the WAF engine. What will happen is that client is generating, for example, I am a client, or you or any one of your anybody is a client who is generating a request from his browser. What happens is that HTTP request will terminate HTTPS request will terminate this TLS at the WAF layer, and then the WAF layer will inspect the header of that request. There will be any header content for any request, any HTTP request. So that will be first inspected. That layer will be first sanitized to make sure there is no malicious content in that header layer or header part of the request. And then the body of that HTTPS request will be parsed, or it will be understood, or it will be decoded by the WAF engine, and it will be inspected. And then if these HTTP traffic is having any pattern and it is matching with any one of the rules, which WAF has, the WAF engine has, it will be scored accordingly. And based on that a score, and based on this threshold, the action will be taking place. For example, the action can be to block it or to allow it. So what happens is that inside an HTTP WAF, what happens when a WAF parses an HTTP request? example, a WAF is parsing an HTTP body. What will happen is that it'll understand the method. For example, it'll understand what kind of method is it, whether it is a get method or a post method, or it is a push method, or it is a patch method. So all these method will be understood, and WAF signature rule set will understand, okay, what kind of methods are generally used by abusers, and it will understand the URI parameters, what kind of like strings are part of this URI and all the other parameters, and what is happening inside the headers. It will inspect the host name, the referrer, the URI agent. Well, let's say if there's an X forwarder header, so all this will be inspected by the WAF engine, even the cookies, and it will understand the payload, what kind of body payload is. Let's say it's an HTML payload or a JSON payload or a form payload. So all this will be understood by the WAF engine against the signature pattern, which is part of the WAF engine. And then also it will inspect the response of the origin as well. Let's say it is not only going to now inspect the request of a client, it will also inspect the response which is coming from the origin, to make sure that sensitive data are not leaking. And finally, it will take its decision, either to block it or to allow it. And once the traffic is passed through this layer, we can make sure these attacks are not part of the application attack, or you could say top-down OAuth attack. So this is how an WAF layer will inspect this, any HTTP traffic. The next layer we have is an API security layer, where the API traffic will be properly authenticated. Its schema will be validated based on the API endpoints, which will be configured by the application owner. And also API layer also has its own WAF rule signature rules. So the API payloads will be scanned through it, and it will be even an application owner can implement rate limiting at this layer to make sure that people are not abusing their API endpoints to pull out hundreds of transactions without having in control over it. So these are the layers you can implement at an API security level. So what are the kind of attacks which an API endpoint can face is that API has their own top-down OAuth things has to be like prevented. For example, BOLA, IDR, like excessive data exposure, shadow APIs. So these are things which will be part of this WAF rules, signature rule sets. Notice API attack growth rate is more than 120% on year-on-year basis at India, against Indian businesses. The next layer we have is the DDoS mitigation layer, where this DDoS mitigation layer will mitigate the layer 3, layer 4, layer 7 DDoS attacks. Layer 3, layer 4 DDoS attacks are attacks against an infrastructure in pretty much it is an like attack through which an attacker will try to flood their ISP or infrastructure. And, but if you talk about layer 7 DDoS attacks, these attacks are happening at the layer 7 layer. For example, an attacker might generate hundreds of get method, post methods, HTTP transaction to flood the application, to make sure that application server is now always processing its request through that kind of attacks. So this layer will mitigate and observe these kind of attacks. When you talk about an secure edge solution provider, through in any unicast POP architecture, we'll be able to distribute the traffic. Let's say an attacker is generating hundreds of GB of attack volume traffic. It will be mitigated through this unicast architecture and through different stubbing setup, which is implemented at the edge POPs, and through rate limiting engines, and how to handle based on the DDoS configuration. For example, we can implement a policy to properly distribute the traffic across the different POPs. So through this manner, you'll be able to mitigate all the layer 3, layer 4 DDoS attacks, and implementing rate limiting or implementing layer 7 based signatures, DDoS attack signatures, we'll be able to mitigate layer 7 DDoS attacks, layer 7 DDoS attacks. So through this way, you'll be able to prevent all the layer 7 DDoS attacks and layer 3 and layer 4 DDoS attacks. When we talk about common layer 3 and layer 4 DDoS attacks are sync attack or sync flooding attacks, UDP flooding attack, UDP amplification attack. But when you talk about layer 7 DDoS attacks, there are method flood attacks, slow low res attacks, meaning to exhaust the server's CPU. The people like attackers initiate slow low res attacks. So these are some common attacks an application might face or will face. When we talk about the next layer or the next engine, we have bot mitigation or bot filtering engine, where these engine will challenge the bots to make sure to prevent and to identify all the bots which are like masquerading as a genuine user. So these challenge mechanisms are in place at the bot layer to identify this layer. For example, well-known common like challenge mechanism, capture challenge. Another now general common mechanism is JS challenge, JavaScript challenge, and there are many other kinds of challenge, cookie challenge, or even crypto challenge, where bot mitigation engine will send out crypto challenge against the client, and the client mission has to endpoint has to execute that to pass the challenge. Then only they'll be able to access that resource. So this through this bot filtering mechanism or through this bot filtering engine, you'll be able to prevent these kind of bot attacks like credential stuffing attacks, scraping attacks, inventory overloading attacks, or even card spraying attacks. So these kind of bot attacks can be mitigated, and even bots which are like which are pretending to be humans, or where their behavior is in a way that it is pretty much human-like, will be identified through behavior analysis. Because of these challenges, we will be able to identify such kind of bots, and we'll be able to mitigate it. This is what any industry best practice bot solution provider follows. Final layer is the final layer is the custom firewall layer, where depending upon the application logic, and application owner can implement this specific policies, custom policies. The reason we have this layer is that WAF layer will identify known attacks because of its signature. So it is generally termed as positive security model. But a custom security or application firewall is termed as WAF layer is termed as negative security model, and custom application firewall is termed as positive security model. The reason being is that based on the application logic, an application owner can implement his own custom policies. For example, if you notice this policy, for example, if request is originating from any Tor nodes, challenge them or block them. So these kind of custom logics, custom application logics, or custom policies can be implemented based on the application need. If application doesn't need such kind of traffic behavior, an application owner can configure it, and through this engine, they'll be able to stop such kind of transactions. And now in VergeCloud, what kind of mitigation application security stack we are providing for our customers are? We are providing these two primary solutions, application solution stack we are providing, security stack we are providing. One is the negative solution security stack, and next is the positive security stack. Whenever our customers' applications are protected by us, whenever their users are passing through our edge, so all these modules will be inspecting the traffic based on the different use cases. For example, to mitigate DDoS attacks, it will be passing through our DDoS engine. So this is not in the proper order. The reason being is that to segregate what is negative security model and what is positive security model, we made sure for this session alone we have segregated in this manner, but it will work in a different logic pattern. But ideally, this is how our traffic passes through our security stack, and this is how it will be mitigated at the edge layer itself, and only we'll send the clean traffic to the destination, that is the application origin. And again, the response also will flow through the same engines, and then it will finally reach the client. So this is what we are doing at the VergeCloud when we talk about application security, which is what we are providing for our customers. And finally, through our analytics solution, our customers will be able to have a complete visibility of what kind of traffic pattern and what kind of attacks are happening against their applications. And now, to summarize some practical steps anybody can take to make sure their application security stacks are properly implemented. So these are the things, common things an application securities or application owners can implement or make sure that these are in place to make sure their security attack surface is reduced and their applications are properly secured. To make sure to first thing they can make sure is that to make sure that they can have a proper WAF in place and its baseline is properly completed and the WAF is in block mode after a certain period of time. And the second thing they can make sure is that they have implemented proper DDoS mitigation strategies and rate limiting strategies against their API endpoints or against their application. And the third thing they can make sure is that they have implemented proper bot security functions in place to mitigate bot attacks. So these are some practical configurations you can implement at any application to make sure they are not properly now safeguarded. And the final thing is that, or you could say the one last thing, any operations team or any DevOps team or any security team can keep or they can follow this practice or this life cycle to make sure they have properly implemented security part of their life cycle or the part of their operation life cycle. Reason being is that it's not just we are implementing a WAF and we are implementing an application security stack. The process is completed. No, instead this process is a continuous life cycle. Whenever we identify, whenever they identify new kinds of attacks or new kinds of attacks happening against their application, and application security solution operation teams they should make sure that it is getting properly detected, it is getting properly isolated, and it is getting properly contained and analyzed, and it is properly getting blocked on an regular basis to make sure that their application security is in place. So this has to be properly implemented as a practice by any security operation team. And last but not least, these are the 4 things I would suggest any operation team to make it as a note or to make sure that this is in their checklist to make sure that their application security stack is properly implemented. First, to verify whether their WAF is running in block mode or in learning mode. Second, to make sure that their origin is properly locked down. Third thing, their API endpoints are properly audited and properly secured. And finally, make sure that whenever there is an alert or whenever there is an attack happening against, or whenever there is a critical alert they are noticing in their application security stack, it has been properly addressed. So these are the things, or even what they can do is that they can properly monitor their server response status or their server response code on average on weekly basis or a monthly basis, what kind of server response they are noticing. So these kind of things they can put there in the checklist to make sure that their proper security stack is properly in place. And finally, thank you for joining this session, and thank you for listening. Now we have the floor open for question and session.
Thank you for the session, Arshad. That was quite a very informative one. And yes, we do have a couple of questions, and most of them have already been answered by your friend and colleague Edu. If you can go through the question and answers, do you want to point out to any of these questions which you think are important? The last 2 questions which have not been answered are by Shubham. He's asking, how did those major data leaks happen if all kinds of attacks are inspected in multiple levels?
If you have noticed, these attack, these data breaches happen due to misconfiguration at their application side. They were not having a proper security stack in place to prevent these kind of attacks. That is why these data breaches has happened in the past. The next question, one interesting question we see is that how do we block attacks against any application which is happening through artificial intelligence or through machine learning systems? So what now people have started adopting at the security side is that security solution provider have started adopting artificial intelligence to safeguard the applications. Not only the attackers are now utilizing artificial intelligence to do the attack. Now even the security solution providers are adopting artificial intelligence to stop these kind of sophisticated artificial intelligence attack. So that is what now industry have started adopting. That is what across all the security solution provider are now doing it in the market.
Well, I think all the questions have been answered. Audience, you can go through the Q&A section and you can see the questions posted by some people, and they have been answered. Well, that was a great 30 to 40-minute session. Thank you, Arshad, for the valuable information. And for those who were asking, a lot of people are asking if we'll get the recording and the PPT for the webinar, yes, you will receive an email within 48 hours. And in that email, you'll get a link to this webinar recording along with the PowerPoint presentation, what has been presented today. And you can also share those videos with any of your colleagues if they have missed to attending today's webinar. So anything else, we'll keep you posted on our upcoming webinars. So yeah, that will be all from our side. Thank you all again for attending our 4th webinar. We hope to see you soon in our next ones. Thank you, Arshad. Thank you, Ishan, and thank you, everyone else.
Thank you for joining the session. Have a good day. Bye.